Daily work unit 1-2. Name 3 segments. So remember that a segment is a part of a line that starts at one point and stops at another. It's the part of the line. If we define segment XQ, it's the part of line XE that contains point X and point Q and all the points on the line that lie between point X and point Q. Now we defined it as starting at point X and stopping at point Q, which is fine. Okay. So that's one segment. The whole distance would be another segment, right? Starts at point X, stops at point E, and then there's another one, obviously. 4 rays. One of the things I would like to say, if you actually have the ray that starts at Q and goes indefinitely through X, don't forget that when you name that ray, you still put the arrow to the right, even though the ray is actually going to the left. And you name the end point of the ray first, Q, and then the point in the direction that it's going second. Okay, so there's ray QX being named properly. Opposite rays, recall, are rays with a common endpoint that go in opposite directions, and so that would be the one going this way and then the one going that way from point Q, right? Opposite rays. Rays with a common endpoint going in opposite direction. So it's going to be Q something and ray Q something. They have that common endpoint and they're going in opposite directions. Name ray XQ another way, and you can handle that one. Segment AD plus segment DJ. That would be segment what? Segment addition. This is a postulate, right? The segment addition postulate. Segment AD, if we go to the picture, goes from A to D. Segment DJ in the picture goes from D to J. So when you put that together, you're actually going from A to J. So segment AD plus segment DJ is equal to segment AJ by segment addition. Always enjoy students when it says find DJ, they go, well, there's D and there's J, so I found them. That's not what it wants to know. When it says find DJ, what does it really mean? Well, it means the distance between point D and point J on that coordinate plane, which means how long is segment DJ. Well, to find that, you're going to take the absolute value of the difference of the coordinates of point D and J. Now, point D would be at -1 and point J would be at 5, so it would be the absolute value of the difference of -1 and 5. -1 minus 5, the signs are the same, so you add and take the common sign, and then the absolute value of -6 is 6. So the distance between point D and point J on that number line would be 6. This is called the ruler postulate, the ruler postulate. Okay? It has more questions about coordinate of the midpoint, AM. It says on number 9, find Phi AM. There's more ruler postulates. Number 10, let's look at that. Name a segment equal to segment AN. Again, I use equal for segments and congruent for segments to mean the same thing, because congruent is same size and same shape. Equal is same size. Segments are always the same shape. So if we say segments are equal, it's kind of given that their lengths are the same and they're congruent. Name a segment equal to segment AN. Well, segment AN starts at A and goes to N. A is at -4, N is at 9. The absolute value of the difference of those coordinates would be -4 minus 9, which would be absolute value -13, which is 13. The other one, would that be that same distance, would be obviously 1 over from here to 1 over from there. So it would be BO, segment BO. And you could calculate its distance using the ruler postulate and verify. And then we want to start getting into this reason. It says if A is the midpoint of QZ, that's saying that point A is the midpoint of this whole big segment QZ. Given that that is true, we can conclude that from Q to A is the same length as from Q to Z, because the definition of a midpoint says that it is the point that divides a segment into two equal segments. So the length of segment QA then would be equal to the length of segment ZA, and again we could put congruent or equal, either one. Some teachers may demand you to put congruent. That's fine. Now, we have the word midpoint and what we get out of it, two equal segments. When you have the word and what you get out of it, your reason will be definition of. And so we're going to have definition of a midpoint. Any questions on those daily work problems for Unit 1, 2? Okay. Now, at the end of that, we have some more draw and label. And let me let you know the expectation. The expectation is not that somebody's going to put point A and then guess at how far 1 3/4 is and put a C, and then guess at how far 5/8 is and put a B, and then just say, well, that's 1 3/4 because we called it that. And this is 5/8 because we called it that. And so we're going to call it good enough, and then we're going to add those up. We're not going to do that. What I expect of my students is that you're going to get a real ruler, and you're going to really measure what 1 3/4 inches is, and you're going to really measure 1 5/8 inches. And when you get through, you're going to measure the entire thing, AB, and see how long it is on the ruler, so you know how to use the ruler. And we're also going to verify this by taking our mixed numeral and adding the fraction 5/8 to it, which we would find a common denominator of 8 for the 5/8 and the 3/4, and we go 4 times what is 8, 2. So 3 times 2 is 6. You can see there's some delay right now on my smartboard, which is really fun when you're teaching, but we'll deal with it until it catches up thinking. I need to shut it down and restart it. It got tired on me. My computer got tired. And so we have 11/8. 8 of those 8s make one whole, so we would carry a 1 and have a 2, and that would leave us with 3/8. And so we have 2 3/8 inches. For how long is AB? Again, my intention is not that you hand scratch it out like I did, that you actually lay out a ruler, you measure exact, and that's where your instructor in class would show you exactly how to do that. Now, let me uh, pause the recording for just a moment, go find a ruler and bring it in so we can actually look at what fourths and eighths and things are on a ruler. We'll be right back. Okay, we're back, but without a ruler, so we're going to create a ruler. And so I'm going to make this a little larger than it would be, obviously. Let's just say that this is 1 inch. Now, if you want to know what a half is, then that would be the mark halfway between there, and it would go down a certain distance, and then that would be your 1/2 inch mark. And then halfway between the 0, which would be here, the end of the ruler, which may or may not be the end of the ruler at 0, there will be a mark that's not quite as far down as the half that's halfway between a half, and there would be 4 of those subdivisions that would make the whole inch, and that would be a fourth, because a fourth is a half of a half. And then there would be a smaller subdivision that would have an even smaller mark, and there would be one of those in between each of the fourth marks, and you could see that it would take 8 of those to make a full inch, and so that would be an eighth. And so that's how a ruler is subdivided. So what you would do is lay your ruler up there, and we would start at our end point here, and we would call that point A, and then we would go 1 3/4 inches. Now, you would obviously go to 1, and then you would have this situation again where you'd have 1 of those, 2 of those, 3 of those at the end of the 1. And that puts you out here at 1 3/4. So this would be 1/8, 1/4. This right here, the 1/4 is 1 2/8, and so that next little mark would be 3/8. And then you have 1/2, which is 4/8. See, 4/8 reduces to 1/2. And so then that next little mark would be the 5/8 mark. And then the next would be 6/8 mark, which is really 3/4. And I just put a fourth while ago to show you that we divided it into fourths. But starting at 0 and working our way over, then that puts us at 6/8, which reduces to 3/4, and you can actually see a picture of 1, 2, 3 of those fourths, 4 of which would make a whole. So we've got to kind of understand how to use a ruler, and that's kind of the basics of the subdivisions of a ruler. So kind of wanted you to know that. Okay? Let's look at some more of these potential drawings here. Uh, uh, I'm sorry, this is doing silly looking stuff. It's doing that because I have it on a tool. I'm going to pause. Let's look at number 17. It says ray AB, AC, and AD share a common endpoint. So ray AB, excuse me, I'm having to get my smartboard to doing what I want it to. Ray AB, we could have point A. You could really go anywhere with ray AB, right? Just put another point B. Ray AC, any direction, just another point C. Ray AD. And some of these drawings have obviously an infinite number of solutions. So you're just kind of being creative sometimes on some of them. Some of them are a little more specific, like opposite rays that have a common endpoint and go in opposite directions. Let's look at number 19. It says John built a rectangular speaker box that was 7 1/8 inches long and 3.5 inches wide. What is the perimeter or the distance around? We know that the perimeter of a rectangle is 2 lengths plus 2 widths. A picture would be something like this, where opposite sides are equal and all of the angles are 90, where we have a top and bottom that are 7 1/8, 2 lengths of 7 1/8, and a left and a right that are both 3.5, or two widths that are 3.5. So the perimeter would be 2 lengths at 7 1/8 each, and 2 widths at 3 1/2 apiece. We could just line them all up and find a common denominator, which would be 8ths, and then make equivalent fractions. 1/8 is 1/8, obviously, and 1/8 is 1/8, obviously, and then we'd say 4 times what, excuse me, 2 times what is 8, 4. So 1 times 4 is 4, so 1/2 is 4/8. And then again, 1/2 would be 4/8. So we add up all the total eighths. 1/8 plus 1/8 is 2/8, and 4/8 is 6/8, and 4/8 is 10/8. 8 of those eighths would make one whole, with 2/8 left over, and that 2/8 reduces to 1/4. So we have 1 and 7 is 8, and 7 is 15, and 3 is 18, and 3 is 21 1/4 inches for the perimeter, or the distance around the speaker box. Well, that's all that we're going over on the 1-2 daily work. And so we will begin Unit 1-3 next time. Thank you.